Hello, boys and girls. So we're going to be on page 41 of the Unit 7A and B packet. First thing we're going to do is on page 41. I want you to go to the second problem here about the pepper. One about the pepper. So it says each pepper is 75 cents. I want you to cross that off. We're going to make each pepper, price has gone up to $2. That's going to be helpful. That's going to help you in the next one. So each pepper is $2. All right. The other thing is if you don't have one available, if you have one at home or in your backpack or something, get a ruler or a straight edge. It doesn't have to be a ruler because we're not measuring. So you could use a folder, a bookmark, a book, something with a straight edge. So we're going to use that later, okay? All right, so we're going to be practicing problems that we've done one similar to this in class, very similar in fact. So if you wanted to try one on your own or you just want to kind of do it a little bit ahead of me and check yours against mine, that's perfectly fine. So we're going to do this page and then we're going to do something a little bit different on the next page. Can't wait. So again, our goal is to find the independent, dependent variables, the input and the output, and then use that to help us write the equation and then create a function table to help show the relationship between the input and the output. So we'll start with this one here. Emma was given 5 seashells. Nice. Each week she collected 3 more. Okay. Let W be the number of weeks and let S be the number of seashells she has total. Which variable is independent, which is dependent? Write an equation to model the relationship and make a table to show how many shells she has from weeks 3 to 8. All right, well, let's start with the dependent variable. What's the output? What's the total? It's going to be S because it says the number of seashells she has total. So we're going to let S equal total. I'm just going to write total seashells because there's not a lot of room. Okay. Independent is going to be the other variable. It's going to be W, number of weeks.
Good morning, everyone. There's bagels.
Sorry for that. Let W equal number of weeks. Okay. So how are we going to get the total seashells? That's going to be S equals. All right. So to find the total number of seashells, she was given 5, and then each week she collected 3 more. So each week she gets 3 more. So to get the total number after, or the number after a certain number of weeks, we would do 3, which is how many she gets per week, times W, which is the number of weeks. But she also started with 5. She just had 5 right off the bat. So no matter what, she's going to start with those 5. We're not multiplying that by anything because that's just what she had at the beginning. So this is actually a 2-step function. We're going to multiply however many weeks went by times 3, but then we have to add on those 5 she had at the start. So that's going to be her total. So we're going to let W is the number of weeks. That's the independent variable, number of weeks. It's W. And then S is total seashells. Okay, which is going to be S. Week 3 to 8. 3 to 8. 3, 4, 5, 6, 7, 8. Total seashells. Well, to get the total seashells, you would multiply by 3. 3 times 3 is 9, plus those 5 extra ones she had. 9 plus 5 is 14. 4 weeks. 3 times 4 is 12, plus 5 is 17. So what's going to happen here with the total number of seashells, it's going to go up by 3 each time because each week that goes by, she gets 3 more. 17 plus 3 is 20. Whoops. The next week she'll have 23. The next week she'll have 26. The next week she'll have 29. So just to check that, 3 times 8 is 24 plus 5 is 29. Nice. All right. Let's try this one about Amelia. Shopping at the farmer's market. She bought a watermelon for $5, and she also wants to buy peppers. Each pepper is $2. Let T be the total cost of the produce and N be the number of peppers she bought. All right, so let's let T, that's the dependent variable. That's the total. So we're going to let T equal, I'm just going to write total cost because, again, not a lot of room. And N is the number of peppers. Let N equal number of peppers. So it looks like to find the total cost, which is T is going to be by itself in the equation. It is the output. It's the total. She buys two things. She buys a watermelon for $5. She also buys a certain number of peppers. So let's start with the peppers first, because that's what she's buying a variety of, perhaps. She's maybe buying more than, well, she could buy one or zero, but she could be buying multiple amounts of peppers. So N is the number of peppers she bought. Each pepper is $2. So you would multiply the number of peppers she bought by 2, but that's only the peppers. She also bought one watermelon, a watermelon. So we're just going to add on that 5 at the end because we're not multiplying that by anything because she's only buying one. So again, this is a two-step function. This is the cost of the peppers, 2 times N, plus the cost of the watermelon will give us the total cost. Let's set up our table. So number of peppers is the input, and that's N. Total cost is T. All right. How many peppers are we going to buy here? 1 to 5. 1, 2, 3, 4, 5. Okay. So 1 pepper, 2 times 1 is 2, plus 5 would be 7. 2 peppers, 2 times 2 is 4, plus 5 is 9. So what's going to happen here? It's going to go up by 2 because each time she's buying another pepper, a pepper costs $2. So the total cost is going to keep going up by 2. 7, 9, 11, 13, 15. So let's just check that. 5 times 2 is 10, plus the watermelon would give you $15. All right. Well, let's see this one. This is a classic. Taxi cab. A taxi cab service charges a flat fee of $7 plus an additional $1.50 per mile. Show the relationship between the total cost and the number of miles. Which variable is, okay, so then it kind of goes through the directions. Make a table to show the cost of 2 to 6 miles. All right. Let's start with the dependent variable. Show the relationship between the total cost and the number of miles. That kind of gives us a clue as to our variables here. I'm going to say, I don't know, T or C. I'm going to say C equals total cost. You could use a different letter, of course. So C is our total cost of the whole taxi ride. And then, I don't know, the other variable would be number of miles. Because depending on how far a person's going in this taxi, that will determine the total cost. So the number of miles could change from person to person. So that's going to be the independent variable. That's the amount that the person would choose when riding in the taxi. So let M equal number of miles. Okay. So for the equation, we're going to start with our dependent variable, C, equals. Now, how much is it per mile? It's $1.50 per mile. So each mile costs $1.50. To find the cost of that, of just the miles, it'd be $1.50 times M. But there's also this $7 flat fee. So no matter what, when you get in that taxi, you have to pay $7. Even if you go a foot, you still pay that $7. That's kind of like an entrance fee. Like if you go to the fair or Darien Lake or whatever, you pay that $7 to get in, and then you pay how much for anything else you buy. So you have to add on that $7. So you're not multiplying that by anything because it doesn't matter how many miles you go. You're still paying that $7 at the beginning, unfortunately. All right. So input is going to be number of miles. That's going to be M. Output is going to be total cost. That's going to be T. Okay, so number of miles is 2 to 6. 2 to 6 miles. 2, 3, 4, 5, 6. So if you go 2 miles, it'd be $1.50 times 2, which is 3, plus 7, which would be 10. Now, every time the number of miles goes up by 1, you're paying an additional $1.50. So if you go 3 miles, it'd be $1.50 more than 10, which would be $11.50. 4 miles is $1.50 more than that, which would be $13. 5 miles would be $1.50 more than that, which is $14.50. And 6 would be $1.50 more than that, which would be $16. Let's just double check that real quick. 6 times $1.50. Well, 2 times $1.50 is 3. So 6 times $1.50 would be 9. Plus 7 would be $16. All right. So make sure you have your straight edge ready. Make sure you got that straight edge, because we're going to try out one here that's going to be a little bit different than what we've done before. So some things are going to be very similar, and one thing at the bottom is going to be quite different. So, but not, I mean, we've done this before, but just not in this type of problem here. So Zinn is buying beverages for a party, which are individually packaged and come in packs of 8. Let P be the number of packages Zinn buys, and T be the total number of beverages. The equation T equals 8P can be used to calculate the total number of beverages when the number of packages is known. Determine the independent and dependent variable in this scenario. Then make a table using whole number values of P less than 6. We're also going to make a little graph. So this is going to look very similar to what we've done before, but we're also going to make a little graph. So let's start with our independent, dependent variables. These are already labeled for us, which is nice. So we're going to let T, that's our dependent, our total, equal total number of beverages. I'm okay if you abbreviate that. Total number of beverages. And independent variable, we're going to let P equal total number of packages. I'm just going to write packs. They already give us the equation, but let's see if we can just make it by ourselves here. T is the total, so T is going to go by itself. There are 8 cans, I guess, in a package. 8 cans or bottles. Cans? I don't know. So 8 things in a package. P is the number of packages, so it would be 8 times P. That's going to be our equation. So to get the total number of beverages, you'd multiply the number of packages by 8. So let's do it. 0 times 8. Well, if you get 0 packages, you get 0 beverages. 1 package would be 8, of course. Then we're going to multiply by 8. 2 times 8, 16. 3 times 8, 24. 4 times 8, 32. 5 times 8 is 40. And 6 times 8 is 48. Now, the best part, the graph. All right. So again, we've done some like this before. This is not, this graph isn't really set up at all, so we're going to have to kind of label a few things. First thing I'm going to do is put arrowheads at the ends here, because these are the axes, the independent are the X and Y axes. I'm just going to make, you don't have to do this, but I'm going to do it just to make these a little thicker, because they're a little bit hard to see. Again, you don't have to do this, but just kind of helps show those axes a little better. All right. This is called the x-axis. That's for the input. The input always goes on the bottom. The input for this particular graph is going to be number of packages. So we're going to label this number of packages. Now, what numbers would go along here? We're always going to start with 0 here, always. Now, the number of packages is just going up by 1. 1, 2, 3, 4, 5, 6. So we'll just count up by 1 on the graph. 1, 2, 3, 4, 5, 6. Okay, so then that's our x-axis. Our y-axis is going to be the output, total number of beverages. So you have total number of bev. And this again is our y-axis. That's where our output goes. That's where the output goes. Now these aren't going up by ones. These are actually going up by 8. So it might make sense to go up by 8 in our graph. We can also go up by 10 because it's kind of easier to count by 10s. But you know what? Let's go up by 10, 20, 30, 40, 50. Let's go up by 10s. Let's do it. Because we don't have to go up by 8s. We could. I'm thinking, well, let's go by 10s. So 0, 10, 20, 30, 40, 50. Okay. So I was thinking about either 8s or 10s, but sometimes in the future we'll have to change this is called the scale, what the numbers are going up by. Sometimes we'll have to change the scale if it's a 2-step function, so this might be good practice for us later on. All right, so 0 packages, 0 beverages, so that point is going to go right here. 1 package, 8 beverages, so 1 package is going to be 8. That's going to be a little bit below 10, like right there. 2 packages, it looks like it's 16. 2 is 16. Well, there's 15 right in the middle, so 16 is just going to be a little bit above. Again, this is going to make a straight line at the end, so be kind of careful where you put your points. 3 is going to be 24. There's 25. 24 would be right below that. Nice. It's looking pretty good so far. 4, 32. 30, there's 30. 32 would be just a little bit above that. 5 would be 40, which is right on the money. 5 or 40 is going to be right there. This looks pretty straight so far. And then 6 would be 48, which is a little bit below 50. There we go. All right. This should line up. It looks pretty good. It looks pretty good. Maybe not perfect. Actually, you know what? It's perfect enough. So now we're going to draw a line, diagonal line through those points. And of course, this is linear because it makes a line. The last thing we have to do is just give a little title. I'm just going to call it Zinn's Beverages. And there's our graph. A beautiful graph, if I must say. Very, very nice, very nice. Okay. All right, so tomorrow or next time, we're going to be looking more at graphs and making some together and on our own, and I can't wait. All right, have a great day. See you soon. Bye-bye.